Welcome. With this video, we begin part 2 of our course, Making Sense of Numbers. Part 1 was Making Sense of Reasoning, and Part 3 is Making Sense of Operations. So here we are now in Part 2, Making Sense of Numbers. Now, today, in particular, for this video, we're going to look at Chapter 3, which is Numeration and Place Value, and Part A, so Early Numeration Systems, Additive. There are two kinds of numeration systems, additive and place value. So in this video today, the additive numeration systems. We'll take a look at basically just what is a numeration system, and then some historical examples, the Egyptian numeration system and Roman numeration. So both of these are examples of additive numeration systems. Numeration systems. A numeral is a symbol used to represent a number. So, for example, 2 is a numeral and 27. Those are both numerals. They're things I write down to represent a quantity. A numeration system is a set of numerals together with rules for combining the numerals to represent numbers. So again, 2 is a numeral, 7 is a numeral, but if I combine them this way, then it has a particular meaning. And if I combine them this way, it means something different. In the first case, it's the quantity 27. In the second case, the quantity 72. We use the Hindu-Arabic numeration system. So we start with the digits 0 through 9, and then we combine them in a variety of ways to indicate quantity. Historically, over the past millennia, there have evolved two different kinds of numeration systems, additive numeration systems and place value. Now, what we use with the Hindu-Arabic is place value, but historically, the first systems to develop were additive numeration systems. So we'll take a look back at some of those. In particular, actually two of them. We'll look at the Egyptian numeration system and the Roman numeration. So, Egyptian. The Egyptians used hieroglyphics, and so they had pictures to represent the different quantities. So they just drew a single stroke to represent 1, and a heel bone to represent 10. A scroll was 100, a lotus flower for 1,000, a pointing finger for 10,000. The fish was 100,000, and the astonished person was 1,000,000. I always like this astonished person. He can't believe, oh my goodness, it's 1,000,000. All right, so he's astonished. Such a big number. So different pictures for the different powers of 10. And what the Egyptians did for this additive system is when they wanted to represent a quantity, they just put together as many symbols as they need. So 23, for instance, has 2 heel bones and 3 strokes. But it doesn't really matter where those heel bones go. As long as I have 2 heel bones somewhere, that's 20. So the system gets a little bit unwieldy as we go. 489, I just have to make sure I have 4 scrolls someplace, 8 heel bones, and 9 strokes. And then here we go. This is how they would represent 200,489. So just make sure that somewhere in there you have 2 fish, 4 scrolls, 8 heel bones, and 9 strokes. And you can see how our system, the Hindu-Arabic system, is much more concise. Now, what would the Egyptians do if they wanted to add 2 of their numerals? So let's say 163 plus 456. Well, you can just write the group on top for 163 and the group on the bottom for 456, and then adding could not be easier in an additive numeration system. All you have to do is mush those 2 groups together. And that's it. You've just added those 2 numbers. Now, there is one more thing that we do at the end to clean up a little bit. Do you see what it is? Look at this. I can gather together 10 of my heel bones, and I realize, wait a second, 10 heel bones, that's the same thing as 1 scroll. And so I can take out those 10 heel bones and replace it with a scroll. And so there we go. Now we see that's a little bit more clearly 619. What about subtracting? Say I want 452 minus 328. Well, once again, I write 452 on top, 328 on the bottom, and I think about taking away. I start with 4 scrolls, and I need to take away 3. Okay, I can do that. I can have 4 and take away 3. I start with 5 heel bones, and I need to take away 2. That's fine. If I have 5 heel bones, I can take 2 from that, 2 from 5. And I need to start with 2 strokes and take away 8. That's where the trouble begins. How do I take 8 away from 2? Well, what do you think the Egyptians would do? Here's what they did. They would take one of those heel bones and say, wait a second, one heel bone is the same thing as 10 strokes. Let's take out that heel bone and put in 10 strokes. So there we go. Now I have 12 strokes on the right, but only 4 heel bones. And when I go to do my subtraction, it's pretty good. 4 minus 3 is 1. 4 minus 2 is 2. And 12 minus 8 is 4. And so they end up with 124. Think about how this reflects our own system. If I wanted to do subtraction, I would write 4, 5, 2, 3, 28. And I start my subtraction. And I start thinking 2 minus 8. And you think, oh, I can't do that. So what do? We take the 5, cross out the 5, and write a 4. And then I stick an extra 1 right there to make that 2 into a 12. 12 minus 8 is 4. 4 minus 2 is 2. 4 minus 3 is 1. So I have just done the same thing that those Egyptians did. That 5 in our system really represents 5 tens. So I reduce it by 1 to get 4 tens. And then the little 1 in front of the 2 to make 12, that's taking one of those tens and pulling it into the ones place. So I get 12 minus 8. It's kind of cool to see in the Egyptian system that process laid bare, just exposed wide open. Let's talk about Roman numeration. The Roman numerals had symbols for 1, 5, 10, 50, 100, 500, and 1,000. As we count from 1 to 10, it's generally additive. So I start with a 1, just an I, and then and I. So I've kind of added my symbols together. A little quirk happens around 4, where I take the symbol for 5, and if I put the I in front of the V, if I put the 1 in front of the 5, then it acts actually as subtraction. So 5 minus 1 gives me 4. All right, and then continuing on, now I have my 5, and then 5 plus 1, 5 plus 2, 5 plus 3 to get my 8. And then I get really close to the 10. I'm just 1 away from my 10, so I do a little trick so I don't have to write 4 ones in a row. I write my 10, but I write the 1 in front. And that makes it 9. And then I come up to 10. Now, how will this system work for the next 10 numbers? Let's take a look at that. So 11, there's my xi, xii, xiii. Now, what do you think it's going to be for 14? Well, the x is going to be there, but now the 4, so xiv. And now 15, xv. 16, I continue in my additive way, kind of adding numbers on there, XVI, XVII, XVIII. Oh, something's going to happen now with 19, XIX. So the original X for 10, and plus an additional 9, that gives me 19. And then I end up with 20. So 20 then becomes XX. I'm adding together my two 10s to get 20. Let's look further down the line. What if I want to do these 10 numbers in a row starting with 181? All right, so let's see. Can we break this down? CLXXXI. So C is 100, L is 50, so 150. The three X's are 30, so the first part, CLXXX, that gives us 180. And then the one at the end for 181. And then we proceed as before, 182, 183. For the 4, I get the little trick with the IV. 185, 186, 187, 188. Okay, what's going to happen next? Can you predict 189? CLXXXIX, we get the IX. And now, something tricky is going to happen with 190. 190 is getting close to 200. So that, in fact, that 90 is just 10 short of 100. So I can use the 10 as a subtractor. And this becomes C XC. So the original C, that first C, represents the 100. But then I have XC. I'm taking 10 away from 100 to get 90. And so this gives me 190. Let's spend a little bit more time looking at this subtraction trick with different values. Again, 1 through 10, I can subtract the 1 from the 5, and I can subtract the 1 from the 9. Let's look at multiples of 10 through 100. So x, 20 becomes xx, 30 is 3x's. With 40, I'm going to take the symbol for 50 and subtract 10 from that. So I get xl. There's 10 before 50. And then L for my 50, and then becomes additive again. 70, 80. Now what's 90? It's my 10 before 100. So XC, and then 100. How about the multiples of 100 through 1,000? All right, pause the video, give this thing a try, and then start it up again when you want to check your work. All right, let's take a look. C, CC, 3 C's, CD, and then we get D representing 500, DC, DCC, DCCC, and then for 900, that's CM, and then 1,000 is just M. Here are some random numbers to start working on. So not multiples of 10, not anything nice, just some interesting things to try to work out. So let's see, how would we write 452? The trick is break this number down into its tens. So what I mean is, think of this as 400 plus 50 plus 2. Let's write each of these separately. 400 is CD. There's my 100 before 500, so that's my 400. 50 L, and then 2 II. So there we go, 452. 309, so my first step, write this, 300 plus 9. The 300, CCC, and the 9, IX. How about 849? So I write this, 800 plus 40 plus 9. Let's do the 800, so DCCC, that's 800. I can put my 10 before 50 to get 40, so that's XL, and then the 9 at the end, IX. All right, for these last three, you try. Write them down, give them a good try, see that you can get the Roman numerals for these things, and then start the video again to check your work. All right, and for 911, we have CMXI. For 1444, MCD XL IV. So 1444. And then for 895, I have 895. Now, how would you write 99 in Roman numerals? Now that you know this subtraction trick, it is so tempting to say, oh, well, 99, that's just 1 before 100, right? So couldn't I write IC? No, do not do this. This is not what the Romans would do. For the Romans, the 1 only acts as a subtractor for 5 and 10. 1 never acts as a subtractor for anything else. And it's like this 10, the 10 acts as a subtractor for 50 and 100, but the 10 never acts as a subtractor for 500 or 1,000. So there we go, my little arrows to help us see that. What we have to do is really write this as 90 plus 9. And so the 90 then becomes XC, and the 9 is IX. So that's how we would write 99 in Roman numerals. How about 49, 999? Like 49, wouldn't it be nice if I could just write IL? But no, don't do that. Don't even think about doing that. 49, I have to write it as 40, XL, and then 9. IX. 999, oh, it is so tempting. Please, can I just write, no, you cannot write IM. So 999, 900 CM, 90 XC, 9 IX. There we go. Another little twist in the Roman numeration system, a bar over a numeral is used to denote a value 1,000 times the value of the numeral. For instance, a bar over 5 indicates 5,000. Here's a larger numeral where the bar is over the 4. So that bar over the 4 now represents 4,000. So this number is really 4,070. So how would you write 13,622? Well, the 13,000, well, that's 1,000 times 13. So I'll start with my 13, XIII, put a bar over that. That's my 13,000. Now I need 600, DC, 22. So 20, and then 2. There we go. Last step, this is up to you. Take these numbers that are given to you in Roman numerals and write them in Hindu Arabic numerals. So take some time, give this your best shot, and then unpause to see the answers. All right, here we go. I'll just throw up the answers, and they are right there. 572, 2,384, 1,905, 7,540. So check your work on that and see that you understand this thing. And that concludes this section on additive numeration systems.